The experiment will determine the resistivity of a wire sample. The results will be proved using Ohm's law rather than measuring resistance. There will be a current flowing through the apparatus. The voltage across the apparatus will then be measured in order to factor resistance into the final calculations. It's important to note that temperature will be maintained at a constant level, as variations in temperature will affect calculations of Ohm's law. The apparatus was constructed in a similar fashion to the module brief for ease of explanation and understanding. A flat piece of wood was cut to a suitable size and marked out appropriately. The use of the 7-24-25 triangle model ensured accuracy of the final dimensions of lengths 1, 2, 3 and 4. Meanwhile, the sample wire was marked and sanded at 25 cm intervals to ensure good conductivity between conductors. This was necessary due to the wire being coated with insulation. The wire was then connected using wood screws as pegging points. The apparatus was then labelled appropriately. As seen, the resistivity of the wire will be found using the equation resistivity ρ is equal to the voltage measured across the sample V multiplied by the cross-sectional area of the sample A, all divided by the current applied through the sample I multiplied by the length of the sample L. In order to determine the cross-sectional area A, the diameter of the wire sample was measured with a micrometer at 12 different points and an average value taken. The diameter was then put into the equation pi d squared over 4 to determine the value of the cross-sectional area. In order to find the length L, the lengths L1, 2, 3 and 4 were verified using a ruler. The apparatus was then connected in series at points 1 and 5 with an ammeter and a power supply unit as shown in the physical layout diagram. In order to induce a specified current, I, the output voltage on the power supply unit was manipulated until the ammeter showed the desired current. 3 different currents were used in order to provide a good data set. To obtain the value of the voltage across the sample V, an oscilloscope was used to measure the voltage drop across terminals 1 to 5. This process was repeated 5 times for each of the different values of current I.
The pendulum swinging, hypnosis is taking control, now you linger.
An experiment into the simple harmonic motion of a pendulum was undertaken. A purpose-built rig was constructed out of wood, as seen, and a screw attached to the main beam, from which a mass was suspended on a 30 cm piece of string, which was coloured red to allow for greater exposure. A protractor was fashioned onto a piece of cardboard, and the angles extended to allow for better measurement. This was then also suspended from the screw, as to allow it to self-level and run parallel to the pendulum arm.
Self-leveling rig.
A slow-motion 4K resolution camera was then used to record the pendulum oscillating, along with a stopwatch for time reference. This allowed for higher accuracy when analysing the videos. The experiment was performed 3 times to reduce potential errors in the final calculations.
We should always dress like this for every video, just to make it look like we're all doing it the same kind of thing.
Right, it's recording.
So then that way it doesn't...
Still going.
The aim of the experiment was to construct an apparatus which acted as a pendulum and to record and interpret its displacement from its equilibrium position in regard to time, in order to interpret the damping factor which opposes the motion of an oscillating body.
Here is an experiment to test the permeability of sand by use of water flowing through it at a constant pressure. The pressure was managed using a wastage pipe that leaves from the head of the system, creating a constant level of water at all times. The structural integrity to keep the water from leaking had to remain as solid and stable as possible at all times. So to solve this, the idea of using grommets arrived to secure the outward pipes. By using food colouring in the water, it helped with finding any leaks. The height of the sample has been made to be the same length between the heads of water. This is to make workings out easier and the pressure constant. Multiple samples were used in each experiment, but measurements of the sand always remained the same. From using multiple samples, we were attaining more results. The outcome can be seen as accurate as possible, in theory.
Action.
Right, so now we're going to start our silver experiment. We've got all our equipment all sorted. Exit pipe, measuring pipe, all going to go through. A nice full up watering can. Giving it our first turn. So we decided to come away from the using the watering can idea. So the second bit, we've now made it so connected to the hose going through. We've learned from it, and as the learning experience goes, we've now got a constant flow coming through, and we are starting to get water into our measuring jug at the bottom. This will be now. This should mean that the sand is fully saturated.
Water that came out of the pipes were measured in the containers that were then placed onto digital scales to gain the most accurate results. This experiment follows the similar workings known as Darcy's law.